Hey, grade fours. So last week we did our perimeter challenge, which ended up being way harder than we thought it was going to be.
And we are not runners. We've learned that.
And so we've just recovered, and we're thinking this week we're going to move measurement into area. So area, we think we can maybe do area without running. So area is like the surface of any flat surface of a shape. So you can, it's how much space is inside that flat surface. So we're gonna think of some ways that we can do some challenges this week, girls against boys again, using other flat surfaces, but we need to figure out the area first.
Okay, so our first challenge is the basketball challenge, but we're gonna have a little bit of a twist to it. We're not trying to get the basketball into the hoop. In fact, we're going to lose a point if we get the ball into the hoop. What we're going to try and do is just have the basketball hit the backboard. So what we want to know is how big of a space are we working with? What's the area of that total backboard?
When we measured perimeter, we used a linear unit. So we used a centimeter, or we used meters. When we measure area, we have to use a square unit, because we have to fill up that flat space with square units to figure out how many of those units it takes to fill up that space. So one example of that would be a square centimeter. So you can see the square centimeter that I've drawn out on this piece of paper. Now, in regards to our basketball backboard, you can imagine a square centimeter is pretty small. So it would take a lot of square centimeters to fill up that backboard and find the area. So we can actually change the unit a little bit. So what we decided to do is that we would measure the backboard in something called a decimeter. A decimeter is a square that contains 100 square centimeters. So this one decimeter here would have 100 square centimeters within it. We measured our backboard and we found that the length of the backboard is 18 decimeters and the width is 11 decimeters. We could take out a meter stick and we could draw out those square units onto the backboard and we could count them up. That's a lot of square decimeters. Okay? But there's an easier way to do this, and we're going to get to that. So let's just kind of review a little bit. So we see all these square decimeters. Okay? I'm just going to highlight one of the decimeters here, and we're going to blow that up. And you can see that if we blew that up, it would actually be, a square decimeter would have 100 square centimeters in it. In other words, it would be 10 centimeters wide, 10 centimeters long. So it's a square. So 1 square decimeter would equal 100 square centimeters. So you can see why we wouldn't want to measure the backboard in square centimeters, because that's just a lot of square centimeters. And we wouldn't want to have to count those, and it's actually a pretty big calculation as well. So if we change our unit to decimeters, that actually makes it a little bit easier to deal with. Let's calculate the area of the backboard. So there's a formula that you will always use to calculate the area of a rectangle or a square. That formula is that the area will equal the length times the width. So pretty simple. All we have to do is multiply the length times the width. So in this case, we're going to multiply 18 decimeters by 11 decimeters. That's our equation. Okay. Now when we work that equation out, 11 times 18 is 198. Okay. Now it says 198 decimeters there. However, it's not 198 decimeters anymore. It is 198 square decimeters. So how do we show that it's not a linear decimeter anymore, that it's a square decimeter? Well, we put this little number 2 here. And that says, that changes that decimeter to read as a squared decimeter. So we read it as 198 decimeters squared. Okay. So that means that there are 198 square decimeters on our backboard.
Okay, so the name of the game is elimination. So both of us will have a throw. If you hit the backboard, you're still in. You take a step back to the next line, you gotta throw again. If the ball goes in the hoop, you're automatically out. The other person wins. Okay? Ladies first.
Challenge accepted. Easy.
Oh, that was close. That was close.
Step back.
Step back. I'm flirting with that disaster here.
Alright. I think because Mr. Gibbs is a little stronger than me, we should have to make him shoot backwards. If he gets this next one in, that's gonna be the next challenge. Oh!
So this is for the win. For the win. Oh! It's a tie. It's a tie.
All right, we're gonna try that one again.
Last shot, so it's like this is tiebreaker time.
Oh, baseball's not really
For the win.
winning. Oh, sorry girls. Sorry girls. Next time.
Okay, so this athletic stuff has gotten a little bit tiring, and I just don't think we're cut out for it. So we're gonna tone things down a little bit, and we thought, hey, what would be a better way to end off some athletics, but with some really tasty microwave cookies? So we want to figure out if we used a cookie sheet this size, and we figured out the area of this cookie sheet this size, will this cookie sheet, with the amount of cookies that we want to put on this, which is a lot, will it fit in that microwave oven?
Mr. Gibbs is the best baker using a plastic cookie sheet in the microwave. Let's see how this
Hey.
goes.
Ask,
I think
challenge your mums. Challenge your mums. Microwave cookies is where it's at.
I think that's too big.
You think it's too big? Well, we'll see. We'll see. Okay. Well, let's measure. So we're going to measure the width first. So remember, it's width times length, or length times width. This is 40 centimeters wide, and the length is 56 centimeters. So 40 by 56 centimeters.
Okay, so again, if we were to imagine all of these were little squares, we would have 56 little squares going this way, and we would have 40 going this way. But we're not going to count them all, so we're just going to do some multiplication. Again, this is double digit. You will not have to do double digit, but we'll still practice it. 56 times 40. I already know everything with my zeros is going to be 0, so I'm just going to put a 0 in my ones place. And then I'm going to move to the number in my tens place. 4 times 6 is 24. 4 times 5 is 20. Plus 2 is 22. So there would be 2,240 little centimeters inside of that lid. For area, we always put the little math symbol squared, a little 2. So that 2 means area.
So 2,240 centimeters squared. That's a lot of cookies. I like the sounds of that, but we have to see if it's going to fit in the microwave. So here now we have to figure out the area of the microwave. So here we go. We're just going to do the flat bottom of the microwave to figure out that area. So it is 37 centimeters. And I'll go this way because then I can see. 37 by 38. It's almost a square.
Okay, so we're going to take our area equals length times width formula. We're going to multiply those two numbers. 38 times 37. 7 times 8 is 56. 7 times 3 is 21. Plus 5 is 26. I'm going to start a new row looking at the number in my tens place. So my new number is going to start in the tens place. 3 times 8 is 24. times 3 is 9, plus 2 is 11. Add it all together. I'm going to do my answer over here. 6. 6 plus 4 is 10. Keep the 0, carry the 1. 2, 3, 4. And 1.
No.
The microwave has an area of 1,406 centimeters squared with that little floating tube.
I don't believe it. I don't believe it. It's got.
Blake was right. Right
Blake.
away, he said it wasn't going to fit. Good estimation skills, Blake. Your dad must be a teacher.
It won't sit flat. My cookies will slap. Okay.
No cookies for you.
Now we're gonna get a little smaller one.
Yeah, we need a smaller
We
one.
do need a small one.
Or a bigger microwave.
Okay. So that's area. And this is Bilawchuk, Mr. Gibbs.